Okay, I want to teach you a few skills that you're going to need for this test. And this one is a fraction. It's already got a common denominator. It's already been put together. I want you to break it apart because that's a crucial skill. And then if you broke it apart correctly, you should be able to simplify it from there. Try that. Yes, ma'am. That's a good question. Could I just replace this with a 1? No, I cannot. If it's not squared, it won't work. If it's a squared kind, like the Pythagorean kind, it won't work if they're not squared. All right, so if you break it up into two fractions, this one's going to be cosine x over cosine x. What's that? That's 1. Plus sine x over cosine x. And what's that? So it's 1 plus tangent is your final answer. You get that? So what do we just learn there? You don't always want to put the fractions together. Sometimes if they're a fraction, you want to pull them apart. Let's do a common denominator one. 1 over tangent, also known as cotangent, plus 2. Make that have a common denominator and add them together. It's a crucial skill. So you put this over 1 because now you can see clearly they do not have common denominators. And then you say, what would be a good common denominator? Tangent. So I'm going to go tangent over tangent. And then I can add the tops and leave the bottoms the same. 1 plus 2 tangent x all over tangent x. How many of you had that one right? Good. Then you have a chance on the test because there's a lot of fraction stuff. Okay, because this is an easy one and there'll be harder fractions to add together. Yes? Yes, that's true. It's cotangent plus 2. But I was asking you to put it together because you need to know how to do common denominators. But I get what you're saying. If you just look at the original problem here, that's a cotangent in front. Yes. But sometimes you don't want that. You want to get something like this because that's what they ask you to prove is that it's equal to this. Yes?
Would you ever be able to cancel the tangents?
No, you cannot cancel these because there's not one here. If there'd been a tangent in all 3 spots, then you could. Let me show you one just like that. Tangent x plus sine x tangent x all over tangent x. Now this time, I want you to factor the top. Factor out what you can out of the top. And I'll think you'll see why that'll be handy. Just the top. Well, I can see the tangent is in both of them. So I can take that tangent out to the front. Times 1 plus sine all over the tangent on the bottom. Now, do you get that I can cancel those 2 tangents? Because this is a multiply here. Then this and this can cancel. Another way to say it is, look, there's 1 in each. Doink, doink, doink. I can cancel it right there. But you just got to remember, when things cancel, they don't disappear. What do they turn into? 1s. And so this would be 1 plus sine times 1, which is just sine, all over 1, and I don't really need the over 1. So it's 1 plus sine. Either way, the answer is 1 plus sine. Do you get that? All right, next thing. What did I tell you to look for when you had something like this? What did I say you might want to think about? Starts with a C. Conjugates. Conjugates. Would you try multiplying this by its conjugate? That's another crucial skill that you need to know for this test. So the conjugate for this puppy would be, instead of sine x minus 1, it's sine x plus 1. And if I do it there, I got to do it here. And then, what's cool about conjugates is that when you multiply them out, the firsts will be a squared, and then you can start using Pythagorean stuff. The outside and the inside are opposites of each other, negative sine x and positive sine x, so they cancel. And the last would be a minus 1 times 1, which is 1. So my denominator here is sine x minus 1. I'm going to try to grab and move it down a little bit here. Ooh. Okay. And then the top of my fraction is 1 times, which really means it's like it's not even there, so it's just sine x plus 1. And then if you wanted to, do you see that this looks a lot like one of those identities you need to know? Which one? It's the sine squared plus cosine squared equals 1, but it's got a twist. Do you get that if I put this sign over here, it would be 1 minus sine x squared, and what I have is sine x squared minus 1, exactly the opposite. And therefore, I don't put in cosine there. What could I put in? Negative cosine. So right in here, you could put in negative cosine because it's the opposite of what the normal thing would be. I'm going to solve to make that really clear. Sine x is equal to 1 minus the cosine. So it should have been, oh, I should have been able to put in 1 minus cosine. Oh wait, I'm sorry, sine x minus, no, I did it wrong. I solved for sine and I should have solved for cosine. Sorry. So I'm going to solve for cosine is equal to 1 minus sine squared. And that looks a lot like this, except it's backwards. So instead of putting in cosine here, I could put in the opposite of cosine. All right, that's the third or fourth, I kind of lost track. That's another important skill, is being able to see if it's the opposite of what you want off the chart, then you can put in the opposite answer. Here's the simplest of that. Negative sine x. Well, if it was just sine x, I could put in 1 over cosecant, right? So I put in negative 1 over cosecant. Oops, my negative blended in there. All right. Next crucial skill, difference of squares. Cosine. Factor that. If you don't know how, it's another problem you won't be able to do. Okay, since this is a difference, wins minus problem, of squares, these both have perfect squares because they're to the 4th power. Then I can put sine squared and sine squared and cosine squared, and then instead of a minus, a plus and a minus. How many of you wrote that right? Good. And what's particularly neat about that one? Come on. It's sine squared plus cosine squared. And what's that? That's just 1. So 1 can be put in instead of that. So then what am I really saying? I'm saying that this, 1 times that, which is that, is equal to that. Isn't that weird? They're the same thing. It's true. Yes? Nope. They'd have to both be opposites. Because before they were both positives, and now you'd have to make them both negatives. You know what I'm saying? Okay. If they were both negatives, then that could be replaced with a 1 also, but it can't. Or a negative 1, but it can't.
So we wouldn't deal with the difference of squares.
No, you could actually factor it farther, but I don't think that'll help anything. All right, so moving on. See if I can think of any more crucial skills for the day. Like when you see something like this, sine squared x, cosine squared x, just remember you got lots of choices. Do you get that I could replace the sine squared with something? Yeah, I could put in many different things. I could put 1 over cosecant. I could put in, is it 1 minus sine or is it sine minus 1? 1 minus sine squared. Cosine, sorry, cosine squared. I could, let's see, sine squared minus cosine squared. It's sort of like, if it was only a plus here, I could make it a 1, but I can't. Can I just make it a negative 1? No, they'd have to both be negative. If it was like this, then I could replace the whole thing with negative 1. That's true. And could I replace cosine with something if I wanted to do that? Yeah, I got lots of options there. I could put 1 over what? Secant. Or instead of cosine, I could put some kind of something with a sine. 1 minus sine squared? Okay. All right. I want to do one for you off of this worksheet E. Let me make sure you're on the right one. I'm going to pause for a second. Number 7 off the worksheet E. This is 5.2E, number 7. Tangent squared x minus sine squared x equals tangent squared x sine x squared x. Thank you. Now the first thing I notice is that I have 2 terms. You see how I have 2 separate terms? And they need to get down to just be 1? What does that tell you? I have to get it down to one thing. How? Maybe get a common denominator, add things together? But they don't even have denominators right now. I mean, could I make them have something different for a denominator? Okay, so what's a good idea? Anybody got an idea? Tangent, make tangent into what? Sine squared over cosine squared. Everybody, please do this. We're going to obviously be leaving the right side alone. We're just messing with the left side here. And then if I go minus sine squared x, do you get how now they don't have a common denominator and now I can try to add them together? So how could I add them together? If they had a common denominator. How do I get a common denominator? I got to get the denominator to be cosine squared, so I'm going to put a cosine squared here and a cosine squared here. I really multiplied by 1 by doing that blue thing. So that's why it's okay to do that. Okay, and so now, if I go sine squared x minus sine squared x cosine squared x all over what? Some people think I should put these together. No, they just are the same, and so my denominator is cosine squared x. Please resist the temptation to try to add them and say 2 cosine squared x's or cosine to the 4th x or something like that. It's just, that is the common denominator. All right, now, you might be thinking, man, this isn't getting any better. Any ideas? Factor out the sine squared on the top. I like it. 1 minus cosine squared x over cosine squared x. Get all we did there? We saw that there was a sign in both of those, and so we took one out and put it in the front. We factored it out. That's factoring is really an important skill. And now, man, this really tests your understanding of fractions. Now do you get that I could put this into 2 fractions? I could say that it's this over cosine and times by this over cosine? So it's sine squared x over cosine squared x times, because this is a multiply in there, by 1 minus cosine squared x over cosine squared x. Now I want to go back and look at where I was supposed to be heading here. Do you see I was supposed to be heading towards tangent and sine? What's that? And what could I put in there? All right, you see I'm getting close? All right, so I'm supposed to have a sine squared and not have that cosine there. Any ideas on? Oh wait, I see where I messed up. Okay, I messed up from here to here. Can anybody tell me where? If I did what I did, the denominator would not be right. Do you see why? You said it already. This times this would equal what? Cosine to the fourth. That's not what I want, is it? Do you get how this should just be a 1? It's this times this. It's a multiply. It's not an add fraction. I was acting like it was an adding fraction. It was a multiply fraction. So now when I'm multiplying across, this times this will give me what I wanted. So there should have been just a 1 down there. And that's going to work really nice because then this part is tangent, just like we wanted. And this part right here, what's 1 minus cosine squared? Sine squared. So it's sine squared over 1, which is sine squared. All right. So you get to see the teacher mess up. It is hard. It is so easy to make dumb mistakes like that. I split up my fractions, and I thought I was doing it right, but this times this needed to equal cosine, and the way I had it, it wasn't going to equal cosine squared, it was going to equal cosine to the fourth. All right. So that is typical what you're going to do on the test. You're going to see, like, maybe I can do this, and you try it, and then maybe you'll even make a mistake in it, but hopefully catch yourself like I did. All right. What were the skills here? First skill was knowing the tangent was sine over cosine. I mean, that's pretty basic. You need to know that. And then it was taking and making a common denominator. That's an important skill. We made our common denominator. Then it was noticing we could factor. See how I had to factor that out to the front? And then it was noticing that this big fraction here could be made into 2 fractions. But I messed up the denominator. But anyway, here's my 2 fractions that I made it into. And once I noticed that, I could go back to sine over cosine is back to tangent. And 1 minus cosine was sine squared. Again, those come down to identities and knowing your identities. So it's like 4 different little tools we needed to solve this one problem. All right, so there's your answer for number 7. It's a pretty tough one. All right. Would you all look at number 6 and see if you recognize what strategy is probably going to work there? What's that word? It's cotangent v minus 1 over cotangent v plus 1 is equal to 1 minus tangent of v over 1 plus tangent of v. All right. Do you see how this one is just like begging for conjugates? It's like everything up there has got a conjugate. Okay? But maybe I don't want to do that anyway, even though I could. I did this with conjugates, and it gets really, really messy. There's a smarter way. It's not like conjugates would be wrong. You could try multiplying by cotangent v minus 1 to fix this. Or you could multiply by cotangent v plus 1 to fix that. And those things would work, but just think. You see how I got a couple cotangents here, and you see over here I got a couple tangents? Can't you change the one side to be like the other side? Like, Can I replace these cotangents here with tangents somehow? What can I replace them with? So I'm going to replace these two right here with 1 over tangents. 1 over tangent v minus 1 over 1 over tangent v plus 1. And then, do you see how this is just begging for a common denominator? Because this is really over 1, and so then I can multiply by tangent over tangent. And then I'll have a common denominator, and then I can add them together. And then do you see how I have big fractions over the top of other big fractions? And this will come out to one big fraction, and this will come out to one big fraction once I get a common denominator. And then I'll have fractions divided by fractions, which you'll have to flip and multiply. And when you do all of that, it'll work. Yes?
So on the top, what would you want to be?
Just read it from the left to the right. We still have this, so what would that be?
1.
Minus tangent of v over tangent of v, yes. And you do the same basic thing on the bottom. And then you can flip and multiply. And then some stuff will cancel. And by changing this to tangents, we want it to get to be like this blue side, which has tangents in it. And I think it will. All right. Don't want to just do that whole problem for you. I wanted to give you ideas how to start it. So, I've been thinking of how I could make a snappy saying for this. I haven't got it together yet, but in the Army they have a saying about I'm not going to quote it here because I'm going to probably butcher it, but I'll look it up for you for tomorrow. But what I'm trying to say is, if it's a fraction, if it's 2 fractions, what do you think you're probably going to have to do? Add them together. If it's 1 fraction, what do you think you're going to have to do? Break it into 2 fractions. Okay? If it's got a conjugate in it, potential conjugate, then you should use conjugates to solve it, probably. Because these aren't as good as if they were squared. If they had a squared in them, then you could use Pythagorean identities. Okay. If you can factor it, factor it. And there's a couple kinds like that, you know, like this. Difference of squares, except ours would say sine to the 4th of x minus, let's say, cosine squared of x. Could I factor that? Yeah, they're both perfect squares. Difference of squares. If you can factor it, factor it. If it's a quadratic, factor it. See how that's a quadratic? It's got a squared thing, something that's not squared, and a number. So it's really like this. And then you can factor it. So if you can factor it, factor it. If it's a fraction, 2 fractions, add them. If it's 1 big fraction, break them apart. I'm trying to just give you all these different strategies, ideas that you can choose. And I also want to lower your concern a little bit. I know these are hard questions, but remember, how many questions are there on Friday? How many you have to answer? 8. 8 you have to answer. The 9th one, if you happen to be done, cool, and you can figure that out, awesome. But you have 8 questions you have to answer. How many of those 8 are going to be hard? Probably 4. Okay, so if we've been learning how to solve and simplify and prove, you're probably only going to have 1 or maybe 2 proofs. You're probably going to have 1 or 2 simplifies, and those are probably going to be on the easy side. You're probably going to have some stuff off identities, you know, like you'll have to know all the different kinds of identities that there are. And those really are pretty easy, as long as you have taken the time you needed to memorize them. And the solving are probably the hardest ones, because a lot of times there's like 4 answers. Because you got to remember, oh, where is sign negative? All students take calc and, you know, draw your circle. And All right. So, I want to give you a fair amount of work time today. We don't have tons of time left, but we got some. And your assignment then is the worksheet E that I gave all the other classes. For this recording's purposes, this class happens to be different because I forgot to give them the worksheet yesterday. So what I want you guys to do on worksheet E is just the front page, those 4, and then the 2 that I did with you in class. Okay, that's all I need you to do from that worksheet, even though there was 12 questions. Okay? Then, your homework due Friday is the other packet, which is the review for the test. I'm going to do a bigger, more formal review for the test tomorrow, where it covers like everything. Okay? And today's more of just a few strategy ideas and then a bunch of work time. Okay? All right. That's the end of the video for today.